Okay, guys, today we start with not a new topic because it's not a new topic, but it's part of the last topic that we have been seeing so far that is called vectors. Okay, so first of all, I want that you notice this vector from here, the vector that you see over there. Okay, I want that you notice it. What do you notice in this vector? What do you notice in this vector? Okay, guys, I cannot stop if you're not participating, so I'm going to tell you what you should notice. Every time I give you a vector, I give you two different things. I give you the value of the vector, and I give you the angle of the vector. And those two make up what we know as the two characteristics of a vector. Vectors have two characteristics that are magnitude and direction. Magnitude is the hypotenuse of the vector. In this example that I showed you above is 100. The magnitude tells you how big or small the vector is, and it is denoted by a number. So I give you 100 newtons at 35 degrees angle. 100 Newton is the magnitude of the vector. It tells you how big the vector is. How big it is? 100 Newton. And the other characteristic is direction, which is denoted with the Greek letter theta, and the direction is related to the angle. In this case, I'm giving you a vector that has an angle of 35 degrees. So for this vector, okay, I'm going to have this angle. The angle tells you where the vector is going. So magnitude tells you how big or small the vector is, and the direction is denoted by the angle that is given in the vector. Now, for those two characteristics, we're going to have two formulas. For the characteristic of magnitude, we're going to have the formula for the resultant. What is the resultant? The resultant is known as a result from adding vectors. So when you add the vectors, the answer that you get after you add vectors, okay, I was thinking about him. Okay, the result that you get when you add vectors is what are known as the resultant, and that is the formula that you see over there. R is equal to the square root of x squared plus y squared. This is the formula. And this formula, I don't know if you look or if you find it familiar, this formula, I already gave it to you by the beginning of the second partial. The only difference is that it had a different shape. The formula I gave you was C is equal to A squared plus B squared. Do you remember which formula is this? Do you remember the name of this formula? It's a theorem. Hi girls, sorry. I'm invading your classroom. Wait. In any case, this formula that I'm showing you in this moment is the one that we know as the Pythagorean theorem. And as you can see, the two formulas are alike, okay? They are very similar. They have the same structure. Oh, that door is noisy. As you can see, the two have a very similar structure. R is equal to square root of x squared plus y squared. And the angle, we're going to get it by using the formula. This formula over here. This formula is angle is equal to only tan is tangent, okay? But tangent to the -1 is known as arctangent. So this formula is arctangent of y divided by x. Now, how are we going to use these formulas? Take a look to this example. Example 1, it says, components method for adding vectors. How many vectors do you see in this example?
Three.
Okay, so we're going to be adding 3 vectors. Now, take a look. The first thing that we need to do with these vectors is we need to analyze the types of angles that we have. So I'm going to focus on the first vector. This angle of 60 degrees. What type of angle is that? Is that horizontal angle or is that a vertical angle?
Vertical.
Take a look. What is the axis that the angle is touching?
Negative x.
It is touching what axis?
X.
X. So when this occurs, we say that we have a horizontal angle, okay? And when we have a horizontal angle, to calculate the x component, we're going to be using cosine. And to calculate the y component, we're going to be using sine. That's why we identify the type of angle from the beginning, okay? So to add vectors, we're going to need to build a table like the one that you are seeing over here. It is a table that has 3 columns. In the first column, you have vector. In the second column, you have x component. And in the third column, you see the y component. Okay? So, 3 columns, vector, x component, and y component. And as a reminder, in your x component, you're going to have positive to the right and negative to the left. And in the y component, you're going to have positive upward and negative downward. Don't forget this. Now, how are we going to use this table? I'm going to make a change. I'm going to move this exercise from the position because I want to have the table next to the exercise. Wait. I know. Wait. Okay. Okay. Now we're cool. So this is the thing. The first thing that we do is in the first column, we're going to draw the vectors, individual vectors, okay? So here, my vector A is going to be placed over here, my vector B, and my vector C. This is a table that I give to all my students where you can add up to 5 vectors. In this example, I have only 3 vectors, okay? So that means that I'm not going to be using the other rows over here. I'm not going to be using these rows because I have only 3 vectors. So let's work with the first vector. In the first vector that I gave you, wait. It doesn't let me work if I don't do that. Okay. So I have my first vector over here. And it has an angle of 60 degrees. So the first thing that I do is I will complete my vector in X and in Y. Okay. It is the same that we have been doing so far. This is going to be your X component, and this is going to be your Y component. As you can see, this vector is going to the left and it's going upward, okay? Because the X component is going left, it's going to be positive or negative. Plus or minus.
X is minus and Y is plus.
Okay? And Y is going up, so it's going to be plus. So what are we going to do? We're going to start working like always, okay? You're going to get the X component and you're going to get the Y component. Just remember, because it is a horizontal angle, for X is going to be cosine and for Y is going to be sine. The angle is horizontal. So we're going to start getting the components now. AX and AY. AX is going to be A cosine of the angle because it's a horizontal angle, and AY is going to be A sine of the angle. And now we're going to replace by the given, okay? The value of A is the value of the vector. This vector is 100 Newton. Okay, so it is 100 Newton. You can see it in the sketch. So 100 Newton cosine of 60 degrees. How much is this? How much is this? You can write it in the chat.
$50.
50. Minus 50 Newton because it's going left. And you apply the same procedure in the Y component. You will replace. How much you get here? This answer is going to be positive because it's going upward.
Give me 86.60.
86.6.
86.60.
And don't forget to write the units that are Newton. With this, we finish the first vector. So we need to continue with the vector B. Vector B is coming in this direction. It has an angle of 30 and it is 80 Newton. So the first thing that I do is I complete the triangle. Where is the vector going? Right, left, up, or down?
Right, and it's going up, so it's gonna be
Be right and up. So it's going to the right and it's going upward. So to the right and upward. And here you can see the two components. The vertical component is upward, so it's going to be positive. And the horizontal component is going to the right, so it's also going to be positive. So now we analyze the angle. What type of angle is this? Is it horizontal or vertical angle? What is the
Horizontal.
axis that is touching? Horizontal or vertical?
horizontal.
Horizontal.
Horizontal, okay? So again, we have a horizontal angle. So the formula is going to be very similar. Bx is going to be using cosine and by is going to be using sine because of the type of angle that we have, okay? So b cosine of the angle, sine equals to b sine of the angle in the other side. And all we do is replace by the given. How much is bx? 16, positive 69.28. Very good, Carmen. 69.28 Newton, and it is positive. Now we calculate By. By is 80 Newton times sine of the angle. How much is By? How much is By? Positive 40 Newton. Thank you, Carmen. Okay, very good. Now, we finished the second vector. We need to work with the third vector. And the third vector is the easiest among all of them, okay? You have the vector C, and it measures 60 Newton. Now, question, is this vector moving horizontally somehow? Yes or no? Is this
It's go
vector?
vertically, but
Vertical.
It's just going vertical. So when this occurs, the horizontal component is going to be 0. Why? Because it's just moving vertically. It's just moving vertically, okay? So your horizontal component is 0. It's not moving to the right nor to the left. So in that case, we say that the component, the horizontal component is 0 because the vector is just moving vertically. And to find the component, the vertical component of the vector is going to be the same vector, but you will include the direction. Because it's going downward, you will place a negative symbol over there. And with this, we finish all the vectors. As you can see, the last vector was the easiest of all of them because we didn't even have to calculate it. What comes after? Because we don't have more vectors, We don't have more vectors. I'm not gonna use the following boxes, okay? Because I don't have any other vector. What comes after is I'm going to add each column vertical. Okay? I'm going to add the first column and I'm going to write my answer here. Here I will get my X and here I will get my Y. So how much is minus 50 plus 69.28 plus 0? How much is this?
No creo.
I got 19.28. Did you get the same answer as me? Minus 50 plus 69.28, 19.28, positive. In the other column, you will add plus 86.6, plus 40, minus 60. How much is this?
66.6.
66.6 Newton. Also, it is positive. Now, this symbol over here represents addition, okay? That you're going to add, and that's what we did. We add the columns. This is a Greek letter that is called sigma. For you guys to know. Now, what comes after are the last two steps that I showed you before, okay? To get the resultant and the angle. So what do we need to do here? Now, one more thing about this. When you get a resultant, you will use only positive values, okay? In this formula, you will use only positive values. Don't forget. So imagine that I give you negative 19.28. Here in the formula, it's gonna be positive. Now to calculate the angle, you will use the signs, okay? The signs that you get, you will use the signs in the second one. Now we apply the formula to get the R. It is 19.28 Newton square plus 66.6 Newton square. In your calculator, this is what you're going to do. In your calculator, this is what you're going to do. 19.28 square plus 66.6 square equals, then you will press the key for the square root and then the key and then equal. How much you got?
On 69.33.
69.33, and these are going to be in Newton. Very good. Now, to calculate the angle, you're going to be using the sign from the formula. The two signs are positive, so there's not a big deal over here. This is equal to arctangent of y, that is 66.6 Newton, divided by x, that is 19.28 Newton. Here you're going to cancel out newtons with newtons. Now in your calculator, this is what you're going to do. You're going to press the key, shift, And then you're going to press the key tan, okay, shift tangent. And then you're going to open parentheses, 66.6 divided by 19.28, close parentheses, equal. How much you got?
73.85.
73.85. This
Yes.
answer is an angle, so it's gonna be in degrees, like that. Now, I want that you guys see what this means, okay? This answer from here represents the horizontal component in a right triangle. This one is the vertical component. This is the resultant or hypotenuse. And this is the angle of the vector. So, what do we do after? We're going to sketch the answer. We're going to work with the bottom of the table to sketch the answer. To sketch the answer, you're going to need a Cartesian plane or coordinate plane, okay? Okay, so take a look to X and Y. X and Y are both positive. So in which quadrant is it going to be located? First, second, third, or fourth? In which quadrant I have positive and positive?
Up and right.
Take a look. This one. This one over here, I have plus and plus. Positive for X and positive for Y. Okay, in this case, you have positive and positive. So you're gonna get a protractor and you're going to measure an angle of 74 degrees approximately, okay? Here is going to be your horizontal component. Why? Because the horizontal component is almost 20, okay? Almost 20. Okay, wait. Sorry, it didn't fit. Okay, so it's gonna be between 70 and 60 for Y, okay? So this is Y. I know. I can't. Well, guys, ni modo. The class is over, but I'm going to continue on Friday, okay? I couldn't work. Kids are back. As you can hear, they're very noisy. So, guys, I'm going to end the meeting now. Sorry for the interruption, and sorry that I couldn't finish. Maybe I can send you another video for you to see how to sketch the vector in the end. And this is going to be it. They're very curious. Say hi if you want. Okay. Bueno, guys, goodbye.
See you, miss.
Bye.
Sí. Ya,
¿Y por qué no me salen, miss?